Good afternoon, YouTubers. Today I will be talking a little bit about an application that I work out in Tinkercad. It's a simulator for electronic components and pretty much straightforward to use. This is sort of like a second video about how I'm planning to add a static RAM to an Arduino. You If you are familiar with Arduino Uno, it has very limited amount of pins, and you are trying to control, for example, static RAM. I have 16 pins, and just for trying to control, I believe that would be 32K, sort of like that. Yeah, a little bit more, a little bit less. So in other words, it's hard. It's hard with an Arduino with limited amount of pins to control a RAM memory. So instead, one thing that you could do is to use a 595 shift register. And the way the shift register works is basically you only need three signals: the data in, a clock, and the buffer. The buffer is when you have the data in X number of clocks. Let's say that 8 clocks. Uh, the next clock, like clock number 9, will keep shifting the number that you want to push into the register. And when you have all set up, then you push buffer out, and the data will light up this part here, which is the LEDs, just for the data that you put into the 595. Down here, these are only used to know what is the counter, how many clocks have you already pressed, because it's going to be hard. I'm doing this manually, but the idea is that the Arduino is the one that will be doing all this clocking and inputting the data and so forth. But this is sort of like a small demonstration about how to do this right. And as you can see, I have some number here, some binary numbers that I will be pushing into my system and see how it goes. There's two reset buttons. There's one here for the binary counter. In case that you don't know what's happening, or you want to start it again with an 8-bit number, and that will reset these LEDs here. This last one here is a reset for the 16-bit counter, and that would be this red one here. All right. And I have some other stuff here, which is basically I'm using a binary counter just to get the proper counting. And these here are to reset the 16-bit counter. It's a little bit more complicated. We'll talk about that a little bit later. If you want to know what they are, you can increase the size of the page here so you can have a better look at them. The 74 AC21 and the 74 AC73. And so I guess that we are pretty much ready to start at least this simulation and see how it goes. For example, one thing that I could do is let's start the simulation. So the simulation is already running, as you can see here. So let's say that I want to press or push this number into this LED. This is an 8-bit count number. So I want to press 1100, 1101 being the most significant, the one, the less significant, the last one here at the end. So if I want to do that, it's as simple as turning the data. So the data now is on. So if I press the clock, which is this push button here, nope, nothing happened. You see, sometimes Tinkercad, you have to align the cursor right where you want it. There we go. And you see that it lit up the first bit. So now I know that I'm clocking, I just did one clock. So for the second clock is also one, so it's already on. So I do it again, there we go. You see I'm counting binary here. So 2 to the 0, 2 to the 1, that would be 2. Now I have to push 2 zeros. So shut this off, and now turn this one clock, another clock. So I pushed those 2 zeros. So how about the 1, 1, and the 0, 1? So turn this, the data on, and now push this, and push again. So you can see 2 to the 0, 2 to the 1, that would be 2, and 2 to the 0, 1, 2, 2 to the 2, that would be 4, that's 6. So I know in binary I'm 6, so that means binary to decimal, I'm the number 6 now. So I'm about to finish when I introduce the 0 and the 1. So 0, that means shut this off, and now you clock. There we go. And now I'm about to enter the last one, which is the 1. Just turn it on, and now push the clock again. Nope. Nope. Align. There we go. And as you can see, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, that would be 8. And so I already have all this number in. It's right within the shift register. It just needs to be buffered out. In that case, just press this push button. No yet. Align properly. There we go. I can press it again. Nothing will happen. Let's see. See? Because I already pressed it. So it's just pushing the data out. It's a little bit of delay. I can see that sometimes you press it and it light up, a few seconds later. It's not a big deal. But anyway, so let's see if these LEDs are showing this data. Being this one here at the end, the most significant bit, and this one here, the less significant. So if you check, I got a 1, 1, 0, 0. That's exactly what I have here. 1, 1, 0, 0, and then 1, 1. That's this one and this one, and 0, 1, 0, 1. That's perfect. So I can try to press this one and just let this the way it is and push all this number down to here. So if I do that, you will have a 1, 1 here when I clock this number in. So let's do it. So the first one is a 1, which is already on. So just clock it. Not yet. Nope. There we go. Perfect. Now how about a 0? And I have to turn this off. Clock it. Perfect. How about a 1? Clock it. Yeah. Nope. Yeah. There we go. That's a 1. And now, let's see. I'm a 0 now. That would be a 0. There we go. Now, I need to press or to clock 1, 0, 1, 1. So let's turn this one on and let's clock. There we go. Now a 0. Shut this off. Let's do it now. Clock. Not yet. There we go. So now I'm about to press, let's see. I think that I did something screwy. Maybe. I think it's bad because I need 0. Let's see. Let me reset the register 1 second. See how you reset everything now? You're back. So let's see if I can fix this mess. I don't think that I had this already reset for it. So let's start again. Maybe I screwed up because there was too much delay on the clock on the simulator. Maybe I hit it twice. I couldn't realize that. So let's see what's the buffer I was doing. Let's see. hard to tell because it was halfway there. So, well, let's start again. Let's press, let's start fresh, 1, 1, and let's do it again. That sometimes happen because you have to watch for, I didn't pay attention to the binary and where we were, and that's kind of screwy. So let's start again. So let's turn this one on, and let's clock 1, 2, not yet, not yet. You see, it's a little bit, there we go. That's 2, but I will be keeping an eye on this one now. 0, 0, that will not happen again. Shut this off, so it's gonna be 0. That's 3, that's 4. 2 to the 0, 2 to the 1, 2 to the 2, that's 4. So I got 1, 1, 0, 0 right in. So I need to push 1, 1. So turn this, and now, no, 1 clock, 2nd clock. Let's be sure where we are. That's number 6. Let's see. 2 to the 0, 2 to the 2 to the 1, and 2 to the 2, that's 4, and 2, that's 6. So I push 1, 2, 3, 4, 5, 6. I'm about to put a 0 and a 1. 0. Shut this off. Clock it. Not yet. There we go. And now you can see that there's one more. That would be number 1. That has to be this on. There we go. Now we're talking. Now we got the first number. I can definitely get that number, buffer that out, and it's right there. But remember, I have other information previously on the buffer, so might be like a little bit because I need to put a reset to all this, but I didn't add that reset button. So let's put the last bit, the last digits, and see how it goes. So the first one is a 1, clock. There we go. And the next one is a 0. Yes, and the next one is a 1. Yeah, there we go. And the next one is a 0. There we go. Now, I'm about to the last 4. So it's a 1, 0, 1, 1. It's a 1, 0, and now a 1, 1. So turn this on. So it's 1 and 1. There we go. I'm right now. I'm perfect. And bit 16 is on, meaning that that was the last 16 digit that I got in. That's A and A. So when I hit the buffer, let's see what happened. There we go. Now, this is the most significant digit. So it's a 1, 1, 0, 0, 1, 1, 0, 1. So what I got here is exactly what it's saying here. 1, 1. So it's 1, 1, 0, 0, 1, 1, 0, 1. Now, this is the less significant of the two pairs. In this case, the last one will be starting from 1, 2, 3, 4, 5, 6, 7, 8. So start here. So it's a 1, yes, 0, 1, yes, 0, 1, yes, 0, and the last 2 digits, that is 1, 1. Perfect. Finally, we got this right. Now, let's push this one here and see what happens. I can certainly leave this binary, the bit 16 on, rather reset it, because I'm gonna start a new counter for 16 bits again. So let's reset that. No, take it. There we go. And let's reset just to be sure that we clean the binary counter. Obviously, everything is off, so no problem there. So let's start with the 3 1. So that's clock 3 times. So it's 1, 2, and 3. Perfect. That's what I got here. And now let's 1, 2, 3. I got 3 zeros. So let's shut this off. And 1, 2, and 3. And now I got 3 1s. So turn this. So I got 1, 2, and 3. Now I got a 0. And now I got 3 ones. So it's 1, 2, 3. And now the last 3 zeros. So shut this off. It's gonna be 1 clock, 2 clock, and you can tell that the last bit is gonna reset the whole all this bit here, and this is gonna go light up, meaning that I'm on number 16, clock number 16. Hit it? Not yet. Here we go. Red light here, indicating that we hit bit number 16, and that we are ready to buffer out all this number. Do it. There we go. So I got 3 ones, 1, 1, 1, yes, and 3 0. So 1 right here. See, after the 3 1, the 3 up. Then I have 3 ones again, yes, and then a 0, and then 3 ones, perfect, and the last 3 bits just 0. Well, that basically, folks, explain a little bit how to set up in Tinkercad the chips register 595, which basically I will be using to handle the addresses of an static RAM memory. Because this one here are, you know, this is the addresses just to get either to push information into the memory or to extract information from the memory as you manage with these 3 signals. You will manage then which is the address that you're talking about, right? Sort of, this is like the first part of the whole business here about how can I expand the Arduino pin limitation using the 595 chip register. Well, folks, that's enough for today. Thank you for your attention. Have a good afternoon.